So here's section 3.2, the remainder theorem for Pre-Calc. Before we actually start this lesson, I'm going to have to go and kind of show you something that you might have done way back in elementary school. Something called long division. And we're going to have to do that first before we actually get to this whole idea of the remainder theorem. Okay? So with your notes, I'd like you to take a look at this. And my first question to you is, hey, do you remember how to do long division? I know many of you forgot that and have been just using your calculator, but let's see if you remember the good old days of elementary school and doing long division the old-fashioned way. So, got this question here. Divide 1205 by the number 7. I don't know if you remember how to do this, but here we go. First thing you do is you take a look at the 7 and you ask yourself, can it go into the 1? And most of you will probably say, And how about then you take a look at, how about 12? So 7 goes into 12 how many times? If you said 1, that's great. So we'll put a 1. And then what do? Oh yes, we took the 1, we multiplied by the 7, we put the 7 underneath. And then after that, we subtracted, so 12 minus 7 is 5. Bring down the 0. Now you're asked to go 7 into 50. I think 7 times would be the correct answer, so 7 times 7 is 49. You subtract once again. 7 can't go into 1, so you bring down the 5. And ask yourself, 7 goes into 15 how many times? Yes, 2 times. 7 times 2 is 14. And then you've got your remainder of 1. These terms, divisor, dividend, quotient, remainder, are pieces of this long division puzzle. What belongs to what? What's the divisor? Yes, that's the number 7, the one you're actually dividing it by. The dividend is the number you're starting with, which is the 1205. The quotient is the answer to your division question, which would be 172. And the remainder would be, yes, the remainder, what's left over, number 1. So I don't know if you remember this idea of the division statement, but this number, it's not 4731, it's, don't know where that came from, sorry guys, it's 1205, cross that out please. So 1205 is actually equal to the number 7 multiplied by 172, and you're going to add 1 to it. And if you're not too sure, bring on your calculator, and let's just double check. Okay, 7 times 172 plus 1, oh yeah, 1205. So the division statement always has the dividend being equal to the divisor multiplied by the quotient, and you have to add on the remainder. Okay? There's an alternate form of the division statement, and this is like in a fractional form. P actually stands for the dividend. Okay? D is the divisor. And I think you know what R and Q are then. So if you use this format, we'll take our dividend, 1205, divided by 7. It's kind of like a improper fraction here. And we know that this equals to 172, right, whole things. And then you've got a remainder of 1/7. So it's kind of like just taking an improper fraction and writing it as a mixed fraction. That's the alternate form of the division statement. Now, what we're doing today, before we do the remainder theorem, is I need to show you how to divide a polynomial by a binomial using long division. And let me just tell you that the same skills that we used just 2 minutes ago doing long division is the same skills we're going to use when we're going to divide a polynomial by a binomial. Just like before, we're going to set it up using the long division method. Now I'm going to show you 2 at the same time. Okay? A numbers way, a polynomial way, and I'll actually write some words to the right hand side here to give you a sense of what's going on. Okay? By the way, before I do that, I have a little highlighting part I need to do. Please remember this. The dividend for the algebra portion, the polynomial, should always be in descending order, so highest degree first. And also we need to insert missing terms using a coefficient of 0. Just like how if I had you say, what's the number 1005? You don't go 1000 blank blank 5s like that. right? You fill in the missing place values with a 0. Same idea here. If I said x cubed plus 5, well, don't forget you need to add in 0x squared, a 0x, and then the 5. It's the same idea, okay? That's what I mean. So let's try this together, okay? Let's do this numbers part first. Okay, we got 21, and we want to divide that into 489. The bigger numbers, okay? So a little bit trickier. What we do is we'll just take a look and kind of do some estimating. So 21 is kind of like 20, and then you're thinking, 20 doesn't really go into 4, but it might go into 48. How many times do you think 21 goes into 48? You might think, oh, it goes in about 2 times. I agree. So write the 2 there. And what's our next step? We took the 2, we multiplied by the 21, and we get 42. That's correct. What's the next step in the long division process? Yes, if you think about it, we subtract. So 48 take away 42 is 6. Now 21 can't go into 6, so what do we do? You're correct if you said bring down the 9. So we'll do that. And then you think to yourself, 21 goes into 69 how many times? Some of you are thinking, oh yeah, probably 3. So we'll write down the 3. And of course we repeat this process. So 3 times 21. What's 3 times 21? 3 times 1 is 3. 3 times 2 is 6. And then yes, we repeat, so we will subtract. And 69 take away 63, give us 6. Alright? That's how we did it during long division. Now I'm going to show you how to do something like long division with polynomials. So instead of having 489, I've now got 4x squared plus 8x plus 9. See the connection there? And instead of dividing by 21, I'm going to divide by 2x plus 1. Okay? So just like over here how we said, okay, 21 goes into 48, you're going to ask yourself, how many times does 2x go into 4x squared? So that's what I'll ask you to write down here if you like words. How many times does 2x go into 4x squared? And the answer is, so think about it, 2x times what gives you 4x squared? Or another way to think about it is just saying, divide 4x squared by 2x. I think we get what? Yeah, 2x. Now I like to line up the x's on top of the x, so 2x, I'll line it up on top of the 8x. Okay, now what's the next step we did? How do we get that 42 over here with the numbers? We did 2 times 21. So guess what we do over here? Yeah, you're right. We do, and I'll do this on the side, we do 2x times 2x plus 1. So 2x times 2x is 4x squared, and that's great. So that matches up with the 4x squared. 2x times 1 is 2x, and we put it underneath. And now what do we do next? We subtract. 4x squared, take away 4x squared is 0. Now be careful here, the minus is to both things, so it's 8x minus positive 2x, and that would be 6x, right on. Okay. So there's 2 terms here, so we need to bring down the 9 as well, so 6x plus 9. And really you're asking yourself now, well, let's do the process again. Now, I guess I forgot to do the procedures in words, so let me try to bring that back. See that blue stuff we did? Yeah, so that blue stuff was multiplying 2x plus 1 by the 2x that we got. And then the black stuff we did here was the subtraction. So I guess the next step was to do subtraction. Okay, and then we brought down the next term, so bring down the term. And now we're ready to repeat the process. So we'll ask ourselves what? I guess we'll ask ourselves how many times does 2x go into, now what are we looking at now? We're looking at 6x plus 9, so we'll just look at the 6x part. So how many times does 2x go into 6x? Or ask yourself, 2x times what gives you 6x? Did you say 3? I hope you said 3. We'll put a plus 3 on the top then. And then, of course, we did 3 times 2x plus 1. So then, of course, we're doing the next part here. Multiply 2x plus 1 by 3. And we distribute, so we get 6x plus 3. And what do we do again after this? Yeah, we subtract. So let's subtract. 6x minus 6x is 0. 9 minus 3, okay, is 6. And there you have it. You've done your first polynomial, dividing it by the binomial. Now, the division statement, let's just quickly review this. Okay, so we've got the division statement for the polynomial. Remember, there are 2 forms, so I'll show you both forms. The first form is where you put the dividend first, so I'll go 4x squared plus 8x plus 9. And remember, the dividend is always equal to the divisor. That's 2x plus 1 multiplied by the quotient. That's 2x plus 3. And we're going to add to that the remainder. Or if you like that fraction form, we take the dividend, we divide it by the divisor, which is 2x plus 1. This equals to the quotient, 2x plus 3. And we're going to add to that the remainder, but of course it's a fraction, so the remainder is 6 divided by the divisor, 2x plus 1. Okay. Knowing this, I'd like you now to turn the page and try the following examples on your own. Okay, so I will do it here too, but I want you to try them on your own and see if you can get the same answers as me. So you can always pause the video and then go and do it yourself and then come back and check your answers. This one though, I also added this thing in called identify any restrictions on the variables. Think back to grade 11, pre-calculus 11. We're doing division, and when we're doing division with polynomials, we have to be careful of what? And if you are thinking about the denominator, yes, right? We cannot have the denominator being equal to 0. So your denominator here really is your divisor. And so looking at example 2a, our restriction, and I'll just do it over here, our restriction is that the divisor, x plus 2, cannot be equal to 0. Therefore, in this case, the polynomial cannot have an x value of -2. Okay? So anyways, I've done enough talking. It's your turn to start doing the division. Enjoy! Here's a hint for those of you who have no clue. Ask yourself, x times what gives you 4x cubed? And you might have said 4x squared. Bravo! And then what do? We took 4x squared and we multiply that by x plus 2. You don't need to write this stuff on the side if you don't want to, but I'm just trying to show it to you. 4x cubed plus 8x squared. Do some subtraction here. Be careful with the negative signs. 4x cubed minus 4x cubed is 0. Negative 11 x squared take away positive 8x squared is negative 19 x squared. We'll bring down the 8x and ask yourself now, x times what gives you 19 or negative 19x squared? Hopefully you said minus 19x. I guess I'm doing negative 19x multiplied by the divisor of x plus 2. I get negative 19x squared. Yay, it matches. It always matches. Minus 38x. And then we subtract again. Notice here, negative 19x squared. Take away negative. 2 negatives put together make a positive. And negative 19 plus a positive 19 give you 0. That's great. 8 take away negative 38 is the same thing as 8 plus 38. That gives us 46x. I'm just going to pull down my next term and ask yourself now, x times what gives you 46x? Oh, oops. Yeah, I think you meant, or you said 46. Now we can do 46 times x plus 2. That becomes 46x. 46 times 2, not too sure, use your calculator. I know it's 92. Last but not least, let's subtract again. The x's cancel. 2 take away 92 is negative 90. There you have it. Okay? So the quotient in this case, so your answer is just 4x squared minus 19x plus 46. This one has a remainder of negative 90. Okay. I'll really stop talking now for part B. Oh, maybe I won't. I will show you one quick thing for this one. At least I will do this for you. Let's write this as 2m minus 1 divided by 8m cubed minus 1. Now, is that good? Or did I forget something? Yeah, if you remember, insert missing terms using a coefficient of 0. You better do that here. So, oops, let's erase this minus 1. Let's put it to the end. Let's put in some missing terms. I like to be positive, so I just keep putting a plus sign. You could be negative and put in a minus. It doesn't matter. Now, do your long division. Careful, 0 take away negative 4m. Ask yourself, 2m times what gives you 4m squared? No. Do some more subtraction. 0 take away negative 2 is positive 2. Hey. Interesting. What do you see here? What's our remainder? 0. Yeah. Okay. So this one, lovely as it is, has no remainder. And of course, that happens quite a bit. We'll talk about what we call these a little bit later in probably the next section. But here's a note, okay? You might not like long division because you think it's really hard and long. Get it, long? Well, there's an alternate process that can be used for dividing a polynomial by a binomial, but it has to be of this form, x minus a. Okay, so it's x minus a particular constant. It allows you to calculate without writing variables and requires fewer calculations. Okay, it's kind of weird though, but nonetheless, I'm going to show it to you. It's called synthetic division. That's an H. Okay, so let's divide this question, which is the same as one above, using this method. Okay, it says how to set up synthetic division. So you do this L bracket thing. And inside the L bracket, I'd like you to write the coefficients of the dividend. So the coefficients of the dividend are these. Okay? So write them in. 4, negative 11, 8, 2. Now to the left of the L bracket, so over here, I'd like you to copy the constant term of the divisor. So the constant term was just 2. Okay? So constant term of the divisor. Now, the next step is to bring down the first coefficient below the L bracket. So here's what I mean. Just bring this down and stick it outside the L bracket. Alright, here's what you do next. You take 2 times 4. And the answer is? Yeah, good, 8. Put it underneath the next term. Okay. Now, we subtract, just like before. What's negative 11? Minus 8. Yes, negative 19. Those numbers look familiar? 4, negative 19. Okay, so we repeat the process. We take 2, we multiply that by negative 19. That gives us negative 38. And then we subtract. So what's 8 take away negative 38? 46. Is that up here somewhere? Okay, let's keep going. What's next? 2 times 46, right? We repeat the process. Equals to 92. 2 take away 92 is? Did you say negative 90? Yeah. Well, look at where these numbers come from, and look at where this number is. Compare it to what we had above. If you look at it, the first 3 terms were the actual coefficients of our quotient. Notice the quotient is always 1 degree less than what we started with in the dividend, because we're dividing by an x. Where's the negative 90? That's the remainder. So look what we've got here. These are now the coefficients of the quotient. And remember, it's always 1 degree less, okay, than the dividend. So really our quotient here, I'll just put on Q, is 4, and it's 1 less, so it's x squared minus 19x plus 46. And can somebody smart tell me what this is? That last number is actually a remainder. So the remainder of negative 90. That's synthetic division. What do you like better? I personally don't care. Now, let me ask you to do one more long division question. Okay, here's example number 3. And I'd like you to do it both ways. Then I'd like you to write the division statement. And then we're going to really figure out what this whole remainder theorem thing is all about. Okay? Our goal here in this section is try to figure out a nice, quick way of finding the remainder. So we don't have to do this long division over and over again. But before we do that, let's do it one more time. Here we go. Using long division, we'll take x plus 1, divide into x cubed minus 2x squared plus 4. What did I forget? Yes, if you said I forgot my 0 term here, you deserve a pat on the back. Remind me in class and I'll give you one. Alright, so don't forget the 0x. Okay, do your long division. X times what gives you x cubed? How about x squared? We'll take x squared times x plus 1. That's just x cubed plus x squared. Okay, by the way, if you didn't see how I got that, once again, that's what I did. We'll subtract x cubed minus x cubed 0, negative 2x squared minus x squared minus 3x squared. Oh yeah, let's bring down the 0x and ask yourself x times what gives you negative 3x squared. How about negative 3x? Okay, negative 3x squared minus 3x. We'll subtract once again. Getting scary. 0 minus negative 3x is positive 3x. We'll bring down the 4. Ask ourselves x times what gives you 3x. How about a 3? 3 times x is 3x. 3 times 1 is 3. We'll subtract one last time, and our remainder is 1. Okay, so we found the remainder. Yay! But it took so long. Boo! Let's do synthetic division as a quick review, and then let's do the division statement, and let's see if we can figure out what's going on in this section. Remember to do the L bracket first. We're going to copy the coefficients of our dividend. So the coefficient in front of the x cubed term is just 1, negative 2. Oops, don't forget the place value holder, and then the 4. We're going to just copy the number outside of the x plus 1 here, which is that. It's just the 1. Our goal here is now to bring down the first number, so that's 1. And now we start that process of multiplication and subtraction. 1 times 1 gives you 1. We'll put it up here. Let's do the subtraction. Negative 2 minus 1, negative 3. We'll do the multiplication again. 1 times negative 3, that's negative 3. We'll do the subtraction again. 0, take away negative 3, positive 3. We'll do the multiplication again. 1 times 3, that's 3. We'll do the subtraction one last time. 4 minus 3, 1. Coefficients, right? X squared minus 3x plus 3 looks the same to me. Remainder, right? Looks the same to me. That's good. So let's write out this division statement. It's the dividend of x cubed minus 2x squared plus 4 equal to the divisor, x plus 1, times the quotient, which we now know is x squared, minus 3x plus 3, and the remainder, yes, of 1. Now, here's the big question. What happens when we plug in x equal to negative 1 in both the left, that's this one, and the right, that's this whole piece, side of the above equation? Okay, so let's take a look at what we get. We'll do the left side first. Left side. Negative 1 cubed minus 2 times negative 1 squared plus 4. Let's evaluate. Negative 1 cubed is negative 1. We have to do the exponents first, so negative 1 squared is 1. Let's keep simplifying. Negative 1 minus 2 times 1, that's negative 2. So negative 1 minus 2 is negative 3, plus 4 gives us 1. Okay. Let's do the right side now. Okay. X plus 1, so negative 1 plus 1 times, okay, the quotient, negative 1 squared minus 3 times negative 1 plus 3. Oh yeah, plus the remainder. Okay. Let's figure out that stuff in red first. Negative 1 squared is 1. 1 plus 3 is 4. 4 plus 3 is 7. Okay. The green stuff, negative 1 plus 1, that's 0. And then we're going to add 1 here. What's 0 times 7? Oh yeah, that's 0. Plus 1. 1. What's so significant about this number 1? Yeah, the left side and right side equal. That's true. But what is 1 from above? If you said that 1 seems to be the remainder, you are correct. So what do you think is a nice, easy way to figure out the remainder now? Should I go ahead and plug it into the right-hand side? That was a lot of work, wasn't it? What about the left-hand side? That didn't seem like it was too bad. But what did we actually do? We plugged in x equal to negative 1 into the dividend, and we got the remainder of 1. Now, why did I choose x equal to negative 1? Like, where did that come from? Well, let me tell you. We did this division question, and we divided it by x plus 1. So what I just did there is, instead of plugging in 1, I plugged in the opposite, which was negative 1, and lo and behold, I got the remainder. Okay? So in general, here's the big thing for today. It says when a polynomial function, p of x, that's this big long thing here, the x cubed minus 2x squared plus 4, okay, that polynomial, is divided by a factor, a binomial of x minus k. Now notice it says x minus k. Okay, so it's kind of opposite of what we have. The remainder is equal to the value of the polynomial when you plug in x equal to k. Remember, opposite. Okay, just like before, how up here, my original question was x plus 1, I plug in negative 1. So this was x minus 1, I'd plug in positive 1, yes. Okay. Or the notation sometimes people use is p of k. What is this thing called? You guessed it. It's in a box. It's important. It's the remainder theorem. Okay. So all you need to do now is go ahead and try to apply the remainder theorem. No more long division. Oh, no more synthetic division. Oh, just go ahead and plug in numbers. So I'd like you to find the remainder when this polynomial, 6x cubed minus 4x squared plus 8x plus 6, is divided by each of the following things. Okay? So we divide by x plus 1, what do we plug in? And if you said yes, we should plug in negative 1, you are correct. So we'll plug in negative 1, 6 times negative 1 cubed minus 4 times negative 1 squared plus 8 times negative 1 plus 6. Go ahead and do that yourself. And if you evaluate correctly, like what I did, you'll get the remainder negative 12. Okay? Next one for B, what do you plug in? X minus 2 is always the opposite, so plug in 2. Go ahead and do that, please, and get the answer. Okay, I got 54. How about this one? Now remember, the polynomial has to be in a particular form. Yes, x minus k. So how can I rewrite this as x minus k? How about just dividing everything by 2? So what do you think I should plug in for this one? Did you say a half? Okay. Plug in a half. Half times half times half, that's 1/8. That's 1/4. That just equals to 4. 6 times 1/8 is 3/4. This is minus 1 plus 4 plus 6. 4 plus 6 is 10, minus 1 is 9. How about 9 3/4? Yes, you can have fractions or a decimal remainder. That's cool. Pretty straightforward, pretty simple. Cool. This is the big gist, okay? So all that stuff from before about the long division was the mechanics to get you to this idea. But the main point of this section is right here in example number 4. Okay. Turn the page. Just a few more examples and we'll be done. Okay, what about this one then? Change it up a little bit. I said find the value of a, and a is like part of the polynomial. If the remainder is 26, when this ugly polynomial is divided by x minus 1. Okay, so we know it's divided by x minus 1, so what should we plug in for x? Yeah, 1, good. So let's do that. P sub 1, or P of 1, sorry, is equal to 2, and we're going to replace x with the number 1. We don't know a, so let's just keep that there as a, and we'll do the rest. 1 to the power of 4 is just 1, so that's 2. This is minus a, minus 11, plus 2a. We'll keep doing this, we'll simplify. That's a, 2 minus 11 minus 9. Oh, so what's this anyways? When we plug this in, this is supposed to equal to your remainder. So how would we solve for a then? I'll say therefore a take away 9 equals to my remainder. I know the remainder is 26. Can you solve for a? Oh yeah, 26 plus 9, 35. Done. Okay. You try number 6 then. So looking at that first part, I think you should be able to find B. Okay? So step 1, find B. Go ahead and do that. And if you thought about plugging in negative 5, you thought correctly. And if you thought this thing equals to the remainder of 73, you thought correctly. 5 squared, 25 times 4 is 100. Minus 5b minus 2 equals 73. Negative 5b. 73 plus 2 is 75, right? I'm going to have to subtract off the 100. So 75 minus 100 is negative 25, I think. Double check my work. I do make mistakes. B equals to 5. Am I done? Not so fast. It then says, what is the remainder when the same polynomial is divided by 2x plus 1? So now, I guess step 2, let's find remainder. And instead of saying divide by 2x plus 1, I'll say when divided by, how about x plus 1/2, right? I'm trying to get into that format of x minus something. And the only reason I'm doing that is because, hey, I don't want to try long division anymore. I'm going to do synthetic division. So by knowing the divisor is x plus 1/2, I know that I put a half out here. Remember, we copied down the coefficients, and the coefficients are 4. The b value, which I know is 5, and negative 2. And we will repeat that process, right? Oh, no, before we do that, we bring down the first term. There's your 4. And remember, process of multiplication, subtraction, multiplication, subtraction. So the first part we do is multiplication. Half times 4 is 2. 5 take away 2 is 3. Half times 3 is 1.5. Don't freak out. Subtract. Negative 2 minus 1.35 is negative 3.5. So what's the remainder? It's this last number. The remainder is negative 3.5. Yay! Okay, the last one here. This one's probably the trickiest of them all. So give yourself a little bit of break if your brain's about fried right now. But this one will only take a few more seconds or minutes. Very similar to example number 6. So for those of you who like the challenge, I'd like you to try to set up example number 7 on your own first. Okay? Always try to do things on your own first before you listen to me. You really don't want to listen to me, right? If you really want to learn better, try on your own. It's okay if you make a mistake, not a problem. That's why it's on video, and no one will know you made the mistake because you're doing it at home. Okay? So let's take a look. This ugly polynomial divided by x plus 5 is a remainder of 2. Okay? So I'm thinking I should plug in negative 5 and a remainder of 2. So I'm plug this in. So that's a times negative 5 cubed plus b times negative 5 squared minus 4 times negative 5 plus 7. And this equals to 2. Let's simplify this, okay? Negative 5 cubed is negative 125a. Negative 5 squared is 25, so that's 25b. 4 times 5, that's 20, and I'm going to add that to the 7, 27, that equals to 2. Going to clean this up a little bit more by just keeping all the variables on the left side, and I'm going to move the 27 to the right side. So 2 take away 7, or 27 is just negative 25. Okay. 2 variables though. We're going to use this again in a sec, but we need something else when we have 2 variables. We need to use some other information. And lucky for us, we do. Divided by x plus 1, the remainder is 30. So let's do the same thing. If I'm dividing by x plus 1, would I plug in? Yes, negative 1. I'm going to put it back into the same dividend with the one with the a and b. And make this equal to how much? 30. Okay. Negative 1 cubed, so that's negative 1, that's negative a. Negative 1 squared is positive 1, so that's just b. Negative 4 times negative 1 is positive 4, plus 7 equals to 30. We'll simplify this. Negative a plus b. 4 plus 7 is 11. 30 take away 11 is 19. Huh. 2 equations, 2 variables. Can you think back to good old grade 10 math? Yeah, you learned a few ways to solve this. either by elimination or substitution, your choice. I'm just going to use substitution because I see this green equation. Numbers are quite nice and easy. Well, the letters at least are. So I'm going to solve for b perhaps. So that means I have to bring the negative a over to the other side. That's 19 plus a. And now I'm going to take this and substitute it into the other equation. So this is the substitution method. Okay, if you forgot how to do this kind of stuff, Chapter 7 of your Math 10 course. Dig up those notes. Okay, I'm going to plug this in now. So here we go. Negative 125a, that's still there. 25, no longer do we use b. What do we use instead? Yes, this 19 plus a. And this is supposed to equal to negative 25. We'll expand this out. Negative 125a. 25 times 19. Well, 25 times 20 is 500. I'm going to subtract a quarter off of that, so, or 25 off of 500, that's 475. 20. By the way, if you just couldn't do that in your head, use a calculator. It's okay. We'll combine like terms. I'm going to move this to the side. I think that's negative 500. Yeah. Oh, look at this. I chose nice numbers for you. We'll divide both sides by negative 100, and a equals to 5. Nice. We done yet, by the way? Oh, it says, what are the values of a and b? Oh, a and b. Well, let's just go ahead and find out b. That's not too hard. B then equals to 19 plus a. A is 5, so b just equals to 24. Ta-da. Done.